Okay, so last time you looked at using the three kinematic equations to solve all kinds of different problems, but now we're going to look at using those in a specific type of situation, which we're looking at is called freefall. So freefall is when objects are falling due to gravity. Okay, so anytime we're talking about an object in freefall, your acceleration is gravity. Okay, so when you're looking at gravity, the value is negative 9.8 meters per second squared, and it's always going to be negative because gravity is pointing down. One of the things you want to be careful with as you're looking through the textbook is they will sometimes make gravity be positive, but what they're doing with this is they're changing their references. So they're saying south in that case would be positive, north would be negative, and they're just trying to make the math easier. I personally think that's really weird and can be confusing, so always keep gravity as being negative because gravity always pulls things down. Okay, so when you're looking at acceleration due to gravity, we're looking at it as being in a vacuum, meaning without air resistance. Okay, and so it's going to be that exact value of 9.8 meters per second squared. The value of gravity does change a little bit depending upon your elevation, so it might be actually negative 9.81, it might be negative 9.807. Okay, it just depends upon your exact elevation where you are. You're going to see minor differences, but for our problems, okay, you're going to use negative 9.8 meters per second squared. Sometimes on the AP test, they will tell you to use 10 instead of negative 9.8 because again, they're not checking to see if you can plug numbers into your calculator. They're checking your concepts. Okay, do you know conceptually what's going on? Do you know which equations to use? Not can you plug and chug. So this is always a constant, so that's why we're getting, instead of just saying acceleration in the y direction, we can actually change the variable to be g. If you want to leave it as ag or ay, that's fine. I'm going to use g just again because it is a constant. So what that means, if you look on this picture over here, is that each second an object is falling, your velocity is going to increase by about 10 meters per second. So after 1 second, your velocity is about 10. Again, we're using 10 instead of 9.8. After 2 seconds, your velocity would be about 20. 3 would be 30. Okay, so each second, your acceleration or your velocity is changing by 10 meters per second. And if you think about acceleration, it's looking at your rate of change of velocity over time. So you're talking about your velocities increasing by 10 meters per second every second. 10 meters per second divided by 1 second would give you 10 meters per second squared. Hence this gravity value. Okay, and then your unit meters per second is meters per second squared. Okay, so let's go through a couple of problems. Okay, so just again using those kinematic equations to solve these problems. So here you have a stone is dropped at rest from the top of a cliff. Anytime it says that something is being dropped, its initial velocity is going to be 0. Okay, because if you're dropping something, then that means at first you're holding it in your hand and then it's going to hit the ground. So that means your v naught y will always be 0 anytime it says that an object is dropped. So this one says an object is dropped at rest. It's redundant. They don't have to tell you that it's at rest. Dropped means that it's starting at 0 because you're holding it still first. From the top of a cliff, it is observed to hit the ground 5.78 seconds later. How high is the cliff? Okay, pay attention that they're asking how high is the cliff. Okay, so since they're talking for a height, you're looking at your distance in the y direction, so you're looking for y. So again, you're going to make your list of your givens. Okay, you don't have to label this out as like, what do I know, what do I want? Just make a list. Okay, show me your work. So my v naught y is 0, my acceleration is g, negative 9.8 meters per second squared. Y naught 0. Okay, that's just telling you your initial height that you're looking at, and then your time is 5.78 seconds. Okay, again, we're not given final velocity, so I want to pick the equation that has nothing to do with final velocity, which is that second equation. Y equals y naught plus v naught yt plus 1/2 gt squared. So I want to solve this first for, I don't have to do any sort of manipulation because it's already plugged in for y. Okay, plug it in and solve. You'll notice I went ahead and simplified here. 1/2 times negative 9.8 becomes negative 4.9. That's where that 4.9 came from, because that's 1/2 times 9.8. 9.8 is negative, so I changed the plus sign to a minus sign. Only time is squared, and you get a y value that's negative 163.7. However, that's how far it fell. Okay, it's supposed to be negative because the object is falling. So, but the question asks, how high is the cliff? So that means when you're talking about a height, you always measure heights going from the ground up. Okay, whenever you measure someone's height, you don't put the tape measure and put 0 at the top of their head and then put the whatever 60 inches, however tall you are, is at the bottom. You always start, whenever you're talking about height goes from the ground up. So since you're going from the ground up, that means your answer must be positive. So that means you would actually take your answer and ignore this negative sign, because this is telling you your displacement. So your mathematical displacement is negative because you're going down, but height assumes and implies that you're going to go from the ground up. So anytime it asks for the height, just make sure your answer is positive. Okay, the next one, you have a pitcher throws a fastball with a velocity of 43.5 meters per second. It is determined that the windup and delivery, the ball covers a displacement of 2.5 meters. This is the point behind the body where the ball is at rest and to the point of release. Calculate the acceleration during his throwing motion. Okay, so you'll notice I threw this one in here. This is not a solid free fall problem. Okay, this one was kind of put in there to trick you up a little bit as you're looking through them, because we are going to start to combine x's and y's when we do projectile motion. So you're not given time, you don't care about time, you're not looking for time, so you want the equation that has nothing to do with time, which is that third equation, vf squared equals v naught squared plus 2a delta x. Again, solve it for a. So it becomes vf squared minus v naught squared over 2x. Plug it in and solve. Which should give you 378.5 meters per second squared. Okay, so again, I snuck this one in here. It's not a free fall problem, but I want you to get used to using x's and y's, because when we do projectile motion, you're going to use x's and y's both in the same problem. And gravity only ever acts in the vertical direction, so when they're asking for an acceleration, don't be tripped just because you think it's in a free fall section. Your acceleration of gravity is only vertical. Gravity acts down. It has nothing to do with your x components that you're looking at. And then this one is one last free fall problem. Not a free fall problem. So just another practice using the kinematic equations. So again, solving for time using that second equation. Okay, so with free fall, okay, you're using the same equations. The only difference is that your acceleration is going to be due to gravity instead. And then if it says that an object is dropped, that means that your initial velocity is 0.